Hello, this module will be NP2 adding fractions. We're going to cover adding fractions with like denominators and with unlike denominators. So at the end of this module, you should be able to add fractions with the same denominators, add fractions with different denominators, and you should be able to solve word problems involving adding fractions. So let's get started. If you have your packet, you can get that out. And I'm going to bring up on my screen what you have in your packet here. So this is the adding fractions packet, adding fractions with the same denominator. And what I'm going to do, get the other thing here. I want this on this side, right there. And what I'm going to do is work through some problems with you. And then you'll get to do some on your own and we'll see how you do. So let's begin here. I just want to make a little bit of white space here for us. Okay, adding fractions with the same denominator. Let's look at row 1. So we're going to look at the spotlight here. We're going to look at this row right here. So this is row 1, and we're going to look at the first one, 2/9 plus 3/9. So I'm going to do a lot of my writing over here on the white space. So we're going to make a little bit of white space below this so we can have some space. So 2/9 plus 3/9. And you can see these written across or you can see them written up and down. So usually you'll see adding done vertically and you'll see multiplying done horizontally. So here is our 2/9 plus 3/9. Actually want to move my plus sign a little bit down. So when you are multiplying numbers that have the same denominator, now the denominator is the bottom number, so that would be the bottom is the 9. So these are the denominators. Denominator here. This is also a denominator. Here. And what do you call the top number? Numerator, yes. So the top number is your numerator and your bottom number is your denominator. Now when the bottom numbers are the same, never, never, never add your bottom numbers together. So your answer will never have an 18 as your bottom number because 9 plus 9 is 18. Do not add them together. Your bottom number will always stay a 9 or whatever the bottom number is for your fractions. So all you do is you take your top numerators. I'm trying to change colors here. You're going to take your 2 and you're going to take your 3 and you're going to add them together. So 2 plus 3 equals exactly 5, right? So this answer is 5/9. So we can put that over here if we want, if it'll fit. On the computer, we got to be a little bit harder to write. 5/9 is the answer to number 1. Okay, let's take a look at the last one in this row right over here. 4/13 plus 6/13. So let's take a look at that one. I'm going to clear my screen here of the unnecessary. And let's take a look at that one. So that is 4/13. 4 is my numerator. 13 is my denominator. I'm going to add to that 6. 13. 6 is my numerator. 13 is my denominator. So my first thing to do is to check, are my bottom numbers the same in these fractions? And the answer is yes, they're both 13s. Now never, never, never add the 13s together. The answer is going to have a 13 in the bottom. And the top, we are just going to add the numerators together. So let's circle those again so we can see where they are. We have a 4 and we have a 6. So we add 4 plus 6, and 4 plus 6 is exactly 10. You guys are good. Okay, so here's a 10. So 10/13 is the answer for this one over here on the end of the row. 10/13. Now later on, as we get more into this, you'll have to maybe be reducing some of the fractions, but at the moment, probably not yet. So the next one I want to do, row 4. So let's clear our drawings and let's roll up to row 4 here and take a look. As you may have noticed, or if you've done some of this packet already, you may have noticed that the problems get increasingly more difficult as you get further along in the rows. So let's look at row 4. We're going to look at the first one here, right here, number 4, 3 and 2/9. So let's write that, 3 and 2/9. Must be a 9, plus 5 and 1/9. There we are. And 4 and 5/9. 4 and 5/9. My first thing I ask myself, are the denominators all the same number? And the answer is yes. These are now not only fractions but mixed numbers as well. Whole numbers and fractions are called mixed numbers. So we're going to make our 9 be our bottom number. That's going to stay a 9. We're not going to add those together. And all we're going to do is add the top numbers. So let's do that. We have a 2, we have a 1, and we have a 5. So when you are doing mixed numbers and adding those together, you're always going to add the fraction side first. Just like you would do if you were adding just regular numbers. You always start from the right and work your way to the left. And that's what we're going to do with the mixed numbers as well. So 2 plus 1 plus 5. That would be, you tell me, 8. Yes, 8/9. Okay, we got the fraction part done. Now we have to add our whole numbers. So we're going to add 3 plus 5 plus 4. Yes, 12. So our full answer then is 12 and 8/9. Let's put that over here on our packet here. 12 and 8/9. Just like that. There we go. Okay, let's try the one at the end here. Let's go to this one right here. So let's clear our screen and draw this one out. So we have 9 and 3/10. 9 and 3/10 plus 2 and 5/10. And while I'm writing this on the screen, go ahead and give it a try on your own and see if you get the same answer that I get. And 4 and 1/10. Here we go. 4 and 1/10. So we're going to add that all together. Add fractions first. We look all the bottom numbers. The denominators are all the same. They're all 10. So we know our answer is going to have a 10 on the bottom. On the top, we have a 3 plus a 5 plus a 1. That's 9/10, right? 9. And then we add our whole numbers. 9 plus 2 plus 4. 15. You got it. 15 and 9/10. So that is the answer over here. 15 and 9/10. So here we go. Okay, so I think you're getting the hang of it. So let's clear our screen and let's go on up to row, I want to go row 5 here. Okay, let's look at the first problem in row 5. 5/8 plus 1/8. Now what's going to happen, as I had said earlier, that fractions are sometimes going to need to be reduced. So this is going to start happening now as we get further along in the rows. So we have 5/8 plus 1/8. 1/8. Here we go. We check and see if our bottom numbers are the same, and they are. They're both 8s, so we know that our answer is going to be something with 8s. And then we add our top numbers. Get a different color here. We're going to add the 5, and we're going to add the 1. 5 plus 1 is exactly 6/8. So now with the 6/8, you can see that there is a number that will divide into 6 and into 8. It has to be the same number. So I am noticing that if I divide the 6 by a 2 and I divide the 8 by a 2, I'm going to put a line over that, we will get, what is 6 divided by 2? 3. What is 8 divided by 2? 4. So 6/8 is equivalent or equal to 3/4. So the answer for number 5, that first one, is actually 3/4. So now you're going to have to start finding that common number that goes into both the top and the bottom fraction. So let's try another one of these. Let's try this one here, 3/16 plus 5/16. I'm going to clear. And if at any time you want to pause the video so that you can keep up with the problems as we're doing them, or you want to write them down or something, feel free to pause, feel free to rewind at any time. And I'm going to clear my drawings. Just these. I'm going to try to keep the 3/4 up there this time. Okay, the next one is 3/16, the one on the end again. 3/16 plus 5/16. 5/16. And we're going to add them together. So again, we check the bottom numbers. They're both 16, so we can just say that the bottom answer is going to have a 16. And the top, we're going to add the top numbers. We're going to add a 3 and a 5, 8/16. Now, if you're noticing, remember we're going to have to be reducing now. So we have to find a number that we can divide the top and the bottom into. So what number goes into both 8 and 16? Well, we could try 4. If you don't see and recognize that it could be a 4, you could do 2, and then you would just do 2 again until you can't divide any further. 8 divided by 4 is equal to 2. 16 divided by 4 is equal to 4. Now notice what happened. I can go even further. So there was a bigger number, wasn't there? I could actually have divided 8 into the top and the bottom. So that's okay. And I wanted you to see that you don't have to get that biggest number right away. You can sometimes have to reduce a couple of times. So now we're going to divide one more time by 2, like this, and divide by 2 on the bottom. Remember, it has to be the same number that you divide the top and the bottom by. So 2 divided by 2 is 1, and 4 divided by 2 is 2. So 8/16 reduces down all the way to 1/2. Okay, so that is our final answer. Be careful on these that you're reducing when you start getting into these fractions. So the key word is reduce, reduce, reduce. Okay, let's try a few more. I'm going to clear my drawing. If you need to pause the video, go ahead. Going, gone. And now I would like to do row number 8. So let's scroll a little bit here. Let's look at the first problem in row number 8 right here. Let's write that out. We have 9 and 2/9. And we have 8 and 1/9. And by the way, my mouse is my right hand here, and I'm actually a lefty, so I'm actually doing pretty good with writing with my right hand here. 7 and 3/9. I'm getting better and better at right-handed writing here. Okay, so now we're gonna add that up, and remember we add the fraction side first. So we have the same bottom number, so we know we're gonna end up with a 9 on the bottom. We add the top numbers, a 2, grab my spotlight here, a 2 plus a 1 plus a 3. Yes, that would give you 6/9. Okay, and now let's add up our whole numbers. 9 plus 8, that's 17, plus 7 more. 18, 19, 20, 21, 22, 23, 24, right? 24. If you don't believe me, go ahead and try that on paper. And notice how I need to reduce my fraction. Can you think of a number that goes into both 6 and 9? It has to be the same number. Yep, 3. 3 over 3. The reason why I can do this and that this fraction will be equivalent to another fraction is because I'm really dividing by 1. Because 3 over 3 is really just 1. And when you divide by 1, you really have the same number. So we're really not changing the fraction other than making it into an equivalent fraction. So 6 divided by 3 is 2. And 9 divided by 3 is 3. So our final answer then, don't forget the 24 is over here, is 24 and 2/3. So that's this one here, 24 and 2/3. Okay, so I don't know if we want to make another little bit of practice on the next one. Let's try one more of these. Let's try this one over here. So we're going to try that one. Erase everything. So this one is 12 and 3/8. 12 and 3. Oh, that's a bad 3. 12 and 3/8, but you can tell, right? But it's there. And 9 and 1/8 right here. And 10 and 2/8. Let's see what happens with this problem. 10 and 2/8. If you want to pause the video and try it first, and then check your work and see if you get what I get, it's a great way to learn. So let's add these up. 3 plus 1 plus 2, 3, 4, 5, 6/8. 6/8. We already know what 6/8 reduces to, don't we? 12 plus 9, that's 21, plus 10 more is 31. And then we take the 6/9 and divide the top and the bottom by the same number. That would be a 2. 2 on the top, 2 on the bottom. That ends up equaling 6 divided by 2 is 3. 8 divided by 2 is 4. We get 3/4. Don't forget there's a 31 there. So that answer is 31 and 3/4. So how do you feel so far? Pretty good? Good. Let's move on. Get a little bit harder. I'm going to clear my drawings and let's go up to row 12. Way over here. Here's our row 12. We're going to do this problem right here. So we have 8 and 3/8 and 3 and 7/8. 3 and 7/8 and 5 and 5/8. 5 and 5/8. And we add that all together. We add the fractions first. The bottom numbers are the same, so we're going to have an 8 on our bottom. We're going to add the top numbers, the numerators. 3 plus 7 is 10. 10 plus 5 is 15. Okay. And the whole numbers is 8 plus 3 is 11. Plus 5 is 16. Now, if you remember back from the packet before this, you have something called an improper fraction right here. Let me circle that. This is an improper fraction, right? It's improper because normally with a fraction, the top number, the numerator, is not bigger than the denominator. So if something is improper, it's not right, right? So if you are acting improperly when you go out to eat, you're probably burping or doing something that you shouldn't be doing, right? That's annoying other people. So improper means it's not the way it should be. So 15 on the top should not be the top number because it's bigger than the bottom number. So we have to change it. Now when we change a number, and I'll keep it blue here so we can see the difference. When we do this, the top number is going to go on the inside of our long division, and the bottom number is going to be on the outside of our long division. And now we've got to say to ourselves, how many 8s go into 15 without going over? Well, 8 times 1 is 8. 8 times 2 is 16. 16 is too high, so only 1 8. So we're going to put the 1 over the 5 because we went into 15. 8 times 1 is 8, and we're going to subtract 15 minus 8. That gives us 7, right? What we're going to do with our remainder is we're going to bring our remainder up here, and we're going to make that the numerator of our fraction. And we're going to make the bottom number be the outside number, the 8. Because remember, we're going to stay with 8 since this whole question is about 8s, right? But now we have one more step, and I'm going to change colors again. We have this whole number 1, right? That has to get added to this whole number 16 now. We've changed 15/8 to 1 7/8, and now we have another whole number that has to get added. So then that would officially give us 16 plus 1. That would officially give us 17. And what fraction is left? 7/8. Yeah, so there. So 17 and 7/8. So a couple more steps getting in there. I think we should do another one. We should do number 12 here. So pause if you need to. Get that down. I'm going to clear my drawings. Okay, the problem next is this one right here. So let's write that one out. We got 2 and 7/12. If you want to pause the video and do it first on your own and see if you get the right answer, feel free to do that, and then we can work through it when you press play again. 8/12. And the last one is 6 and 9/12. That's a 2. 6 and 9/12. Okay, let's add these up. So we have 12s on the bottom, so we know our bottom answer is going to be 12s. And then we add our top numbers. 7 plus 8, 15. 15 plus 9, 24. And then we add our whole numbers. 2 plus 8 is 10. 10 plus 6 is 16. Now again, we have an improper fraction right here because we can't have a top number bigger than the bottom number. That is just not proper. So again, we will take our division and we will do long division. We will divide the 24 on the inside of the long division because that's the top number. And the 12 goes on the outside because that is the bottom number. So how many 12s go into 24? Exactly 2. 2 times 12 is 24. And 24 minus 24 is 0. This one does not have a remainder. There is no fractional part. I mean, I could bring this up here, but it would be 0 over 12, which we don't really do. It's just 0, right? So really all we have is this whole number, 2, that has to get added to this 16. So 16 plus 2, 18. So the answer to this is really just 18 and no fraction left over. So that one is 18. So you could have that happen. I'm going to clear my drawings now. Okay, now I'd like to go to the next level here. Now we're going to change to where we have different denominators. And we have to do an extra step for that. So I'm going to actually roll this up a little bit higher. You're welcome to look at those examples as well after the video too. So we have 3/4 plus 1/2. And the one I'm doing is row 1, the first one. So we cannot add these fractions together the way they are. Why? Because we're talking about different things. This is like a pizza that's cut into fourths and we eat 3 of the pieces versus a pizza that's cut into halves and we eat half the pizza or 1 piece. Those are different size pieces. So you would have learned that in the last packet, more about that. So what we want to do now is we have to get a common denominator. So I am going to change colors here. We have to think, what number could we use that will work for both of these? Well, what if I put a 4 here? I would say 2 times what number gives me a 4? 2 times 2, right? Gives me a 4. So if I times it by 2 on the bottom, I have to times it by 2 on the top. So 1 times 2 is 2. Now this 3/4, we don't really have to change it, do we? Because it's already got a 4 on the bottom. So I'm just going to rewrite it next to it, just so everything lines up. So now we can add 3/4 plus 2/4 because we're talking about the same sized pieces. So 3 plus 2 is 5. And again, it's fourths. We're still never going to add those bottom numbers together. And now you'll notice that 5/4 is improper. So we'll change colors again. The next step then would be to divide the 5. And as you get good at this, you can just do it in your head a lot of times. How many 4s go into 5? 1. 4 times 1 is 4. 5 minus 4 is 1. We're going to take the 1 up here and make that the numerator of our fraction. And the denominator will stay fourths. So the final answer then is 1 and 1/4. Let's go ahead and write that over here. 1 and 1/4. Okay, so far so good. Let's try the end one right here, 5/9 plus 2/3. So I'm going to erase all of this. So we have a little bit more room. Okay, so 5/9 plus 2/3. 2/3. If you want to pause the video and try it first, go ahead. Otherwise, watch me. We have to come up with the same bottom number because we ask ourselves, are the bottom numbers the same? No. So we have to change them so that they are. I happen to see that 3 will work with a 9, so I'm going to change my bottom numbers to 9ths. So I'm going to put a 9 there. This will be a 9. Does it look like a 9? It's a better 9. How many 3s, or what do I have to multiply 3 by to get to 9? 3 times 3, right. And I have to do the same on the top. Whatever I multiply on the bottom, I have to multiply that same number on the top. So I have to multiply a 3 on the top. So 2 times 3 is 6. And then the top fraction, I'm just going to keep it 9ths because it's already 9ths, right? Why would I change it? So 5/9. And now I can add 5/9 plus 6/9. 11/9. And again, my fraction's improper. So I'm going to divide by putting the top number on the inside and the bottom number on the outside. How many 9s go into 11? 1. 9 times 1 is 9. 11 minus 9, 2. That remainder comes up to become my numerator of my fraction. The 2 goes on top, and the 9 becomes my bottom denominator. So the answer is 1 and 2/9. So let's write that in over here. 1 and 2/9, just like that. Okay. All right, so far so good. I want to go on to do row 3. Let's try a couple problems in row 3. So I'm going to hit clear all. So let's look at row 3. Let's try this one over here, right here. So 7/10 plus 1/3. Now we've got 3 numbers here. How are we going to find a bottom number, right? And then 11/30. We have to find a bottom number that's going to work for a 10, a 3, and a 30. Well, what could we use? I know that 10 times 3 will give me 30, and I know that 3 times 10 will give me 30, so I'm going to use 30s right here. So 10 times 3, we said, gave us 30, so I times it by 3 to get to 30. And I'm going to times my 7 by the same number, 3. 7 times 3 is 21. Do the same with this one because they all have to be 30s now. 3 times what gives me 30? 3 times 10. Squeeze that in there. So I have to times by 10 on the top. 1 times 10 is 10. And the last one, 11/30, I can keep that as just 11/30 because it's already got a 30 on the bottom. So now I just have to add my numerators together. And I get 30 on the bottom because that stays a 30. And on the top, I have 21 plus 10 plus 11. So that's going to be a 2 right here. And then it's going to be 2 plus 1 is 3 plus 1 is 4. 42. 42/30. Now, again, that's improper. So the top number goes on the inside. And the bottom number goes on the outside. And you might even be able to figure this out in your head as you're getting better and better at this and practicing. How many 30s go into 42? Well, just one. 42 minus 30 gives us a 2 here. 2 minus 0 is 2. 4 minus 3 is 1. So 1 and 12/30. Okay, but now getting harder now. That's supposed to be a 30th. We have to reduce 12/30. So it's not going to be just 1 and 12/30. We have to reduce by, what number will go into both 12 and 30? See if you can think of it. Yeah, 3. 12 divided by 3 equals 4. And this will be my 4. Going really slow. 30 divided by 3 equals 10. And are we done? Or is there a bigger number? I could have went 12 divided by 6 and 30 divided by 6, couldn't I? So I've noticed that I've got 4/10 and I can divide one more time, can't I? I can divide by a 2 here, and I can divide by a 2 on the bottom. So I could have just divided by 6 right away. But if you don't recognize that, just keep dividing until you can't anymore. 4 divided by 2 is 2. 10 divided by 2 is 5. So 2/5. So my final answer then, don't forget the 1 is still over here. My final answer then is 1 and 2/5. So I'm going to erase everything in between and bring my 1 over to go next to its partner here. So that answer is 1 and 2/5. So getting to add more and more steps. Okay, let's clear our drawings. And stay with me here. The next row I would like to do is row 2 over here. So we're going to do a problem here, right here. 4/7 plus 3/4. So 4/7 plus 3/4. Now this time I've got to change the bottom number of both fractions because a 7 I can't multiply anything by 4 to give me 7, right? So I'm going to figure out what number will work. Well, here's a method that will always work. You can always multiply the two bottom numbers together, and that can become the bottom number that you use. So 4 times 7 is 28. So that can be my bottom number for both fractions, right? That will always work. Sometimes there's something smaller that will work, but if not, you can always use 4 times 7 or the two bottom numbers and multiply them together. So 7 times what gives me 28? 7 times, 4, right? So I times 4 on the top, times 4. 4 times 4 is 16. Here I have 4 times what gives me 28? 4 times 7. So I have to times 7 on top. Don't get mixed up by that. Make sure you're timesing by the right number. 3 times 7 is 21. And now I can add 16 plus 21. 6, that gives me 7. So it gives me 37 over 28. Again, we have to change it to a mixed number because it's improper. 37 divided by 28. How many 28s go into 37? 1. I subtract 37 minus 28. And I get, well, 8 won't be, you can't take an 8 into a 7. So the 3 becomes a 2. This becomes 17. 17 minus 8 is 9. 2 minus 2 is 0, so just a 9. 1 and 9 28. Now, will that reduce? Grab our red thing here. And which one did we do? Down here. So the answer is 1 and 9 28. I don't think there's a number that will reduce into both 9 and 28. The only thing that works with a 9 is a 3 or a 9. 9 doesn't go into 28 and 3 doesn't go into 28. So that's our answer for that one. Okay, that was row 2. Let's do row 4. Okay. Let's do the one on the end here, right here. 2 9ths plus 1 half plus 5 6. So 2 9ths plus 1 half. Now we have 3 numbers, right? Plus 5 6. And we got to figure out what number will work with all of these numbers. What number will divide into all of these? What number will multiply together to give us one specific number? So let's say equals, equals, and equals. And we got to have a number on the bottom. Can you think of any number? The least common multiple is what we're looking for. So if I go 2 times 9, I get 18. I know that 18, 9 will divide into 18. 2 will divide into 18. How about 6? Will that divide into 18? 3 times 6, right? So we're going to use 18 as our bottom number. Common to all 3. It's the least common multiple. And we'll put that here. So 9 times what gives me 18? 9 times 2. Make sure you times by 2 on top then. 2 times 2 is 4. 2 times what gives me 9 or 18? 9. I almost said it, didn't I? So times 9 on top. 1 times 9 is 9. And then 6 times what gives me 18? 6 times 3. And I times by 3 on the top. 5 times 3 is 15. So now I have to add my top numbers. My bottom number is going to be an 18. And my top number is going to be 4 plus 9 plus 15. 9 plus 4 is 13 plus 5, 14, 15, 16, 17, 18. Carry my 1 up here. 1 plus 1 is 2, so 28. I think that's right. 25, 24, 29. Yep, 28. And then we have to divide. It's an improper fraction, so we have to put 28 on the inside and 18 on the outside. So only one, right? 2 times 18 is 6, 36, right? So only one 18 will fit into there. Subtract out 28 minus 18, we get 0 and 1. So we get 1 and, bring it up, 10 18ths. 1 and 10 18ths, just like that. But we can reduce 10 18ths. So let's go back to our red color. So I'm going to make a little room here by getting rid of this part. We know it's 1 and 10 18ths. A little bit more room for us. Hopefully you got that down. So 1 and 10 18ths. What number will divide into the 10 and into the 18? Yeah, 2. So divide top and bottom by 2. 2 over 2. 10 divided by 2 equals 5. 18 divided by 2 equals 9. Don't forget we got that whole number 1 there, right over here. So the final answer is 1 and 5 ninths. Okay? All right. Pause if you need to. I'm going to clear this. And I'm going to go to, let's see what row 8 has for us. Okay. We'll try this one right. Oops. This one. Oh, pooey. There we go. Trying to grab my little wand here. Right here. This one. So 6 and 1 6. 6 and 1 6. Plus 4 and 3/4. Now we're getting a mixed number in here, but our denominators are not the same, so we get a lot of steps, right? First thing we do is make sure our bottom numbers are the same before we can add anything. So we got a 6 and a 4. Well, we could multiply 6 times 4 and use 24, right? As our bottom number, but there is a smaller least common multiple. Have you thought of 12? 12 will work for both. I know that 6 goes into 12 and so does 4. So 6 times what gives me 12? 2. I multiply by 2 on the top. 1 times 2 is 2. 4 times what gives me 12 on the bottom? 3 times 3 over here. 3 times 3 is 9. Now I add 9, 10, 11, 12. And that one doesn't have to be reduced, does it? No, it's got an odd number on top and an even number on the bottom. And don't forget to add your whole numbers. 6 plus 4, 10. So the answer then is 10 and 11 12. And on these ones, they want you to realign them vertically so that you can do this. It's always easier to line your fractions up vertically when you're adding or subtracting, especially when you have to change the denominators. So there is the answer to 8. Let's try row 14. Getting harder and harder. So let's do this one right here, 11 and 7/8. 11 and 7/8. Plus 5 and 3/7. 3/7 and 1/2. So 1/2 is going to be lined up with the fraction side, not with the whole number side. Okay? So now we have to figure out what number on the bottom can we use for an 8, a 7, and a 2. Well, if I do 2 times 8, I get 16, but 16 won't work with 7. If I do 3 times 8 is 24. 24 won't work with 7. If I do 4 times 8, that's 32. 32 won't work with 7. 5 times 8 is 40. That's not going to work with 7. 6 times 8 is 48. That won't work with 7. 7 times 8 is 56. 56 will work with 7 and 8. Will it work with 2? Yeah, so it's going to have to be 56. That's the least common multiple. There's nothing smaller, so let's do this. 56 and 56. 8 times what gives us 56? 8 times 7, so times 7 on top. 7 times 7 is 49. 7 times what gives us 56 here? 7 times 8, so times 8 on top. I'm drawing 8 here. 3 times 8 is 24. And then 2 times what gives me 56? Well, if you don't know, use a, well, you probably can't use a calculator on the test, but you can do this. It's long division. 2 goes into 5 twice. 2 times 2 is 4. 5 minus 4 is 1. Bring down the 6. 2 into 16 goes 8 times. So 28. So 2 times 28. So then I have to multiply the top number by 28. Getting a little crowded here with my numbering here. So 1 times 28 is just 28. So now we have to add together 49 plus 24 plus 28. So we have 9 plus 4, 13 plus 8 more, 14, 15, 16, 17, 18, 19, 20, 21. Put down the 1, carry the 2. 2 plus 4 is 6, plus 2 more is 8, plus 2 more is 10. 4, 5, 6, 7, 8, 9, 10, all over 56. Right? And we got to add the whole numbers. 11 plus 5 is 16. And I'm still not done because I've got an improper fraction. So I'm going to have to fix that by, change my colors, taking 101 on the top, on the inside, the top number on the inside, and 56 on the outside. Well, we know that it'll only go in there once, right? If I was to multiply 56 times 56, I'm going to get 112. So only one time. So 101 minus 56, like this. So we can't take a 6 from a 1. We can't borrow from that. We have to borrow from the whole 10. That becomes 9. This becomes 11. 11 from 6 is 5. 9 from 5 is 4. So then we've got 1 and 45. 45, 56s. And I don't think there's a number. 6 times 9 is 54. I don't think there's a number that will reduce 45 56s. So that answer is right here, 1 and 45 56. 7 times 8. Yeah, I don't think there is a number. 3 doesn't work, not for both. 2 doesn't work for both. Yeah, so that's the answer to that one. Okay, we're almost done. Let's clear our drawings. Estimating answers. This can seem a little weird at first, but it's really not that bad once you understand what you're doing here. So let's take a look at this right here, number 1. 5/16 plus 1/2. So half of 16 is what? Half of 16 is 8, right? Half of 16 is 8. That's exactly half. So if the first one is 5/16, 5/16, is that less than a half or more than a half? Compare the 5 and the 8. 5 is less than 8, so 5/16 is less than half, right? 8/16 will reduce down to half. So we have 5/16 plus 1/2. So if we're going to have a number that's a little bit less than 1/2 here, this 5/16 is a little less than 1/2, and one that's exactly 1/2, is our answer going to be greater than 1 or less than 1? Exactly. It's going to be less than 1, right? Because if you have to have at least another half to get to 1, right? So the answer in that box then is going to be less than. So remember that the open mouth always points to the bigger number. So in our case, 1 is going to be the bigger number. And I always like to draw this Pac-Man guy like here. And I say the Pac-Man guy eats the bigger number. So you can use that if you want. Okay, so that's how you do those. Let's go down and look at number 3. Let me clear my drawings. Number 3 is 1 1/2 plus 2 3/4 between 3 and 4 or between 4 and 5. Well, this is estimating, right? So we don't have to actually figure it out, but we can get a nice guess here. And 2 and 3/4. So we have to decide which numbers are more than half, less than half, or equal to half. Well, 1/2 is equal to half. 3/4. Is that more than half or less than half? More than half, right? So we know that 1/2 plus 3/4 is going to be a whole number 1 plus something else, right? Plus some part of a fraction, right? Some fraction part. And then we add 2 plus 1 is 3. So we know that we're going to get to add this 1 over here. So we're going to get 4 plus some part of a fraction. So the question is, it's number 3 over here. Is the answer to this between 3 and 4 or between 4 and 5? Well, we know it's going to be at least a 4 and some fraction, right? So it's going to be between 4 and 5. So the answer to that one then, it's going to be between 4 and 5. So that's estimating. Number 7, you're going to do just the opposite of what you did in number 3. So let's take a look at that one. So number 7, right here, in problem 7 through 10, write the 2 consecutive numbers and the answer that the answer comes between. So 4 and 7/8 plus 3 and 9/10. 4 and 7/8 plus 3 and 9/10. Now we just have to figure out if it's more than half, less than half, exactly half. So 7/8, what's half of 8? 4, right? So 4/8 would be half. This is a 7. So 7 is more than half, right? 7 is more than 4/8. So this is going to be more than 1/2, greater than 1/2. Okay. The bottom fraction is 9/10. Half of 10 is 5. So 9 is much greater than 5. So this is also going to be greater than 1/2. When you have two numbers that are greater than 1/2, you're going to get a whole number answer, right? A 1 plus some fractional part, right? So let's add our whole numbers. 4 plus 3 is 7. We're going to end up adding this 1 to the 7 and having a fraction left over. So what numbers is it between? The answer is going to be between 8, 7 plus 1 is 8, and 9. So here you got to actually write the numbers that it's between. If I have time for one more, let's take a look. This is word problems. Let's just do number 5. So I'll circle that one. We're going to do this one right here. 1 week, John spent his evenings trying to convert his attic into an extra bedroom. Monday night, he worked 3.5 hours, 3.5 hours. Tuesday night, he worked 4 1/3 hours. And Wednesday, he worked 2 3/4 hours. That's a bad 3. And Thursday, he worked 3 2/3 hours. How many hours did he work on his attic that week? So this is an adding problem. So you have to come up with a common denominator. We have a 2, a 3, a 4, and a 3. So we could use 12 because 12 will work with 3, it'll work with 4, it'll work with 2. So we would use 12. So I'm not going to go through this whole problem because we're running out of time here, but we're going to use 12 as our bottom number for each one of these, and then we're going to just do our adding and solve it. So if you need to reduce, don't forget to reduce. If you get an improper fraction, don't forget to divide it out into a mixed number. Add the whole number portion to the other whole numbers and see what you get. So all of these word problems are adding fractions. So with that, I am going to stop my share and say good luck to you, and I hope you do well, and we'll see you next time. Bye.